Good morning. Let us continue the second session of the second chapter, that is units and dimension. Continuing further, let us consider this dimensional analysis. What is dimensional analysis? Analyzing any equation by the method of dimensions is called as dimensional analysis. ಓಕೆ, ಸೊ ಹಾಗಾದ್ರೆ ನಾವು ಪ್ರಪ್ರಥಮವಾಗಿ ಡೈಮೆನ್ಷನ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ ಎ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಆರ್ ದಿ ಪವರ್ಸ್ ಆರ್ ಎಕ್ಸ್ಪೋನೆಂಟ್ಸ್ ಟು ವಿಚ್ ದಿ ಬೇಸ್ ಕ್ವಾಂಟಿಟೀಸ್ ಆರ್ ರೇಸ್ಡ್ ಟು ಗೆಟ್ ದಟ್ ಕ್ವಾಂಟಿಟಿ. ಬೇಸಿಕಲಿ ಈ ಡೈಮೆನ್ಷನ್ಸ್ ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಈ ಘಾತಗಳು, ಬೇಸ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅನ್ನ ನಾವು ಯಾವ ಘಾತಕ್ಕೆ ಏರಿಸ್ತೇವಲ್ಲ ಆ ಘಾತಗಳಿಗೆ ನಾವು ಡೈಮೆನ್ಷನ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಉದಾಹರಣೆ ತಗೋಣ ಒಂದು. ಸೊ ಈ ತರ ನಾವು ಲೆಂತ್ ಅನ್ನ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ನಲ್ಲಿ ಬರೆದ್ವಿ ಅಂತಂದ್ರೆ ಇಟ್ ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ ವಿ ಆರ್ ರೈಟಿಂಗ್ ದಿ ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ ಲೆಂತ್. ಸೊ ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ ಲೆಂತ್ is equal to L1 M0 T0. So here L stands for length, M stands for mass and T stands for time. So ಈ ಲೆಂತ್ ನಲ್ಲಿ ಮಾಸು ಇಲ್ಲ, ಟೈಮು ಇಲ್ಲ. Therefore we are making the powers to 0. M raised to 0, T raised to 0, but it has length, therefore L1. So you can also write the dimensions of length as simply L. So how we read this? Dimensions of length are 1 in length, 0 in mass and 0 in time. Okay, next, similarly dimensions of mass. How can we write here? Mass has no length, no time, but it has only mass. Therefore we can write it as L0 M1 T0 or simply M. So dimensions of mass are 0 in length, 1 in mass and 0 in time. What about dimensions of time? Dimensions of time we can write it as L0 M0 T1 because time has no length, no mass, but it has only time. Therefore we can write it like this or simply T. Dimensions of time is T. So basically dimensions are powers to which the base quantities L, M, T are raised to get the given unit. In first year we are not using temperature or electric current as base quantities. Only we deal with LMTs. Then what is dimensional formula? Dimensional formula is the relation which represents a physical quantity in terms of its dimensions. For example, so velocity. What is velocity? Velocity, it is rate of change of displacement or displacement divided by time is velocity. If you write its dimensions now, it becomes dimensional formula. So dimensions of velocity is equal to dimensions of displacement divided by dimensions of time. Displacement is nothing but it is the shortest distance between 2 points. In other words, it is length only. So displacement has the dimensions of length and time dimension is T. So T is in the denominator. If it comes to the numerator, it becomes T raised to minus 1. Therefore dimensions of velocity we can write as LT minus 1. In wordings we say dimensions of velocities are 1 in length, 0 in mass, minus 1 in time. Next, let us consider some other quantities and try to find the dimensional formulae for them. Acceleration. What is acceleration? Acceleration is the rate of change of velocity or change in velocity divided by time. So if you write dimensions of acceleration, it is dimensions of change in velocity divided by dimensions of time. So change in velocity is again a velocity, so it has the dimensions of velocity. In the last slide I showed you how dimensions of velocity are LT minus 1. So it is LT minus 1 divided by T. So T, if it goes to the numerator, it becomes t raised to minus 1. So dimensions of acceleration are L t minus 2. Its dimensions are 1 in length, 0 in mass, and minus 2 in time. Similarly, momentum. What is momentum? How we define momentum of a body? It is the product of mass and velocity. So dimensions of momentum is equal to dimensions of mass into dimensions of velocity. So mass dimension we can write as simply m, and velocity dimension we have already seen that it is Lt minus 1. So it is Lmt minus 1. That is the dimensions of momentum. ಇದೇ ತರ ಮುಂದುವರೆದು ಫೋರ್ಸ್ ಮತ್ತು ಪವರ್ ಡೈಮೆನ್ಷನ್ಸ್ ಏನಾಗ್ತದೆ ಅನ್ನೋದನ್ನ ನಾವು ತಿಳ್ಕೊಳ್ಳೋಣ. ಫೋರ್ಸ್, according to Newton's second law, F is equal to ma, that is force is mass into acceleration. So we can write the dimensional formula like this, and you can see here that mass dimension is m and acceleration dimension is Lt minus 2. So force dimension becomes Lmt minus 2. So it is force has dimensions of 1 in length, 1 in mass, and minus 2 in time. Similarly, work is nothing but it is force into displacement. So how can we write the dimensional equation? Like this: dimension of work is equal to dimension of force into dimension of displacement. Dimension of force we have already obtained here, so same thing I am going to write here. Into displacement dimension is nothing but dimension of length into L. So it is L into L is L square m t minus 2 becomes the dimensions of work. Next, and you should note that energy and work have the same dimensions. Next, let us go to power. Power is nothing but rate of doing work. Power is equal to, how can we write the equation? Work divided by time. So power dimension is dimension of work divided by dimension of time. So work dimension we have already obtained here in the previous section. So it is L2 mt minus 2 divided by t. So t, when it goes to the numerator, it becomes t raised to minus 1. So it becomes t raised to minus 3. So power dimension is L2 mt minus 3. Unitless and dimensionless quantities. How to understand this? So a physical quantity that doesn't have any dimensions in length, mass, time, temperature, or an electric current is called as dimensionless quantity. So you ಐದು ಇರಬಾರ್ದು. So such quantity is called as dimensionless quantity. For example, any pure number 2, 3, 5, pi, e, all these are dimensionless quantity. So in addition to that, plane angle, solid angle, amount of substance, luminous intensity, all these are dimensionless quantities. Why? Because we cannot express these in terms of these 5 base quantities. That's why we call them as dimensionless quantities. Next, what is unitless quantity? A unitless quantity is one which doesn't have units. For example, specific gravity. Specific gravity is a unitless quantity. Why? Because specific gravity we can define as specific gravity of an object is equal to density of that object divided by density of water. So in the numerator and denominator we have density. Therefore, those two units get cancelled. So specific gravity doesn't have any unit. Next, strain. Strain is nothing but it is a change in dimension divided by original dimension. Both have the same unit. Therefore, again strain becomes unitless. Efficiency. Efficiency we can define in a variety of ways. So one definition is output power divided by input power. So both have the unit of power, therefore efficiency also has no units. So one important thing you have to note that unitless quantity is dimensionless, but dimensionless quantity need not be unitless. ಅಂದ್ರೆ ಎಲ್ಲಾ ಯೂನಿಟ್ ಇರದ ಕ್ವಾಂಟಿಟಿಗಳಿಗೂ ಡೈಮೆನ್ಷನ್ಸ್ ಇರೋದಿಲ್ಲ. ಆದ್ರೆ ಒಂದು ಕ್ವಾಂಟಿಟಿ ಡೈಮೆನ್ಷನ್ಲೆಸ್ ಇತ್ತಂತಂದ್ರೆ ಅದು ಯೂನಿಟ್ಲೆಸ್ ಇರಲೇಬೇಕು ಅನ್ನುವ ಯಾವುದೇ ನಿಬಂಧನೆ ಇಲ್ಲ. ಉದಾಹರಣೆಗೆ ನೀವು ಈ ಪ್ಲೇನ್ ಆಂಗಲ್ ತಗೋರಿ. ಈ ಪ್ಲೇನ್ ಆಂಗಲ್ ಇದು dimensionless quantity, but it has a unit of radian. Therefore, you have to remember this. Next, applications of dimensional analysis. What are the applications andre uses? ಈ dimensional analysis ಇದ್ದು ಉಪಯೋಗಗಳೇನು ಅಂತ. So first one, it is used to check the correctness of an equation. ಒಂದು ಸಮೀಕರಣ ಅದು ಸರಿಯಾಗಿದೆಯೋ ಇಲ್ಲೋ ಅನ್ನೋದನ್ನ ನಾವು ಡೈಮೆನ್ಷನಲ್ ಅನಾಲಿಸಿಸ್ ದಿಂದ ತಿಳಿದುಕೊಳ್ಳಬಹುದು. ನೆಕ್ಸ್ಟ್, ಟು ಕನ್ವರ್ಟ್ ಯೂನಿಟ್ ಫ್ರಮ್ ಒನ್ ಸಿಸ್ಟಮ್ ಟು ಅನದರ್ ಸಿಸ್ಟಮ್. ಒಂದು ಯೂನಿಟ್ ನಿಂದ ಇನ್ನೊಂದು ಯೂನಿಟ್ಗೆ, ಒಂದು ಸಿಸ್ಟಮ್ ದಿಂದ ಇನ್ನೊಂದು ಸಿಸ್ಟಮ್ಗೆ ಯೂನಿಟ್ ಗಳನ್ನ ನಾವು ಪರಿವರ್ತನೆ ಮಾಡುವಾಗ ಡೈಮೆನ್ಷನಲ್ ಅನಾಲಿಸಿಸ್ ಅನ್ನು ಉಪಯೋಗಿಸಬಹುದು. ನೆಕ್ಸ್ಟ್, ಟು ಡಿರೈವ್ ದಿ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಆಲ್ಸೋ ವಿ ಕ್ಯಾನ್ ಯೂಸ್ ಡೈಮೆನ್ಷನಲ್ ಅನಾಲಿಸಿಸ್. ಸೊ ಈ ಉಪಯೋಗಗಳನ್ನು ತಿಳ್ಕೋಬೇಕಂದ್ರೆ ಪ್ರಪ್ರಥಮವಾಗಿ ನಾವು ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜಿನಿಟಿ ಅನ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜಿನಿಟಿ ಇಟ್ ಸ್ಟೇಟ್ಸ್ ದಟ್ all terms on both sides of the physical equation must have the same dimensions. All terms on both sides of the physical equation must have same dimension. For example, we have this famous equation v is equal to u plus at. It is a kinematic equation. So here v is the final velocity, u is initial velocity, a is acceleration and t is time. v ಅಂದ್ರೆ ಅಂತಿಮ ವೇಗ, u ಆರಂಭಿಕ ವೇಗ, a ಅಂದ್ರೆ ವೇಗೋತ್ಕರ್ಷ ಮತ್ತು t ಅಂದ್ರೆ ಕಾಲ. ಈಗ ಇದರಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಟರ್ಮಿನ ಡೈಮೆನ್ಷನ್ಸ್ ಅನ್ನ ನೋಡೋಣ. ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ v is lt minus 1 because it is a velocity. Then u is also a velocity, it is initial velocity. So dimensions of v is also lt minus 1. Then what about this at? Dimensions of at is equal to a. Acceleration unit is, acceleration dimension is lt minus 2 into t. So it becomes what? lt minus 1. So you can see that all the terms on both sides of the equation have the same dimension, which is lt minus 1. So this is what is called as principle of homogeneity. So now let us consider the first application, that is checking the correctness of equation. So I have taken three equations here. First one is x is equal to ut plus half at square. So here x is displacement, u is initial velocity, t is time and a is acceleration. And you can note that dimensions of x is equal to L because displacement dimension is L. Then second term is ut. So ut dimension is u dimension, initial velocity dimension is lt minus 1 into dimension of t is t. So t minus 1 and t, so they get cancelled. So what is left is L. Similarly, at square, acceleration dimensions is lt minus 2 into t square dimension is t2. So this and this get cancelled. So it becomes t raised to 0, which is 1. So we get L. So you can see that dimensions of each quantity is the same, which is L. So according to principle of homogeneity, this equation is dimensionally correct. Let's take the second equation. V square is equal to u square plus 2ax. So here V is final velocity. So V square dimension is LT minus 1, square of that. So it is L square T minus 2. Next, U square dimension. Because U square and V square both are velocities, its dimension is also L2 T minus 2. Then what about AX? 2 is dimensionless, don't consider it. So what about the dimensions of AX? A is acceleration. So it is LT minus 2 into L. So it will be L square into L square T raised to minus 2. So L2 T minus 2. So each term has the same dimension of L2 T minus 2. So according to principle of homogeneity, this equation is correct. And next consider this E is equal to mc square, Einstein's famous mass energy equivalence relation. E is equal to mc square. Here E is energy, m is mass, and c is the speed of light. So energy dimension we have studied in the previous slides that ನಾವು ಹಿಂದೆ ನೋಡಿದ್ವಿ. ಅದರ ಡೈಮೆನ್ಷನ್ ಏನಾಗ್ತದಪ್ಪ ಅಂತಂದ್ರೆ ml2 t minus 2 energy dimension. Then what about mc square? M dimension is m. C is nothing but it is a velocity or speed. Speed dimension is lt minus 1. Square of that is L2 T minus 2. So each term, dimension of E and dimension of mc square both are same. So according to the principle of homogeneity, this equation is also correct. Next application is conversion of units. How can we convert unit from one system to another system? If a quantity x has dimensional formula LA, MB, TC, and if L1A, M1B, T1C and L2A, M2B, T2C are units in two different systems, and N1 and N2 are numerical values in two systems, then obviously N1 U1 is equal to N2 U2. For example, I can write here 1 meter is equal to 100 centimeter. Two systems are involved here. One is MKS system or SI system, in which the unit of length is meter, and second system is CGS system, in which unit of length is centimeter. So this is U1, this is U2, and this is N1, this is N2. These are numerical values in two systems. Just you have to understand like this. Then N1 U1 is equal to N2 U2. So N1 into this L1A, M1B, T1C is equal to N2 into L2A, M2B and T2C. So how can you write N2? N2 is written as N1 times L1A, M1B, T1C divided by L2A, M2B, T2C. Then using this relation, how can you prove that 1 Newton is equal to 10 raised to 5 dyne? Note that Newton is SI unit of force and dyne is CGS system of force. So how can you do that? You know that dimensional formula of force is LMT minus 2. This you have to note. Then write this equation. N2 is equal to N1 into L1A, M1B, T1C divided by L2A, M2B, T2C. So N1 I write as it is. Here I write this as L1 by L2 raised to A. Next M1 by M2 raised to B, T1 by T2 raised to C. And N1 is 1. It is obvious that 1 Newton is there. So N1 is 1, that I am writing here. Then unit of length in SI system is meter. L1 is meter. L2 is unit of length in CGS system, that is centimeter. So meter by centimeter raised to 1. Why raised to 1? Because see, compare this equation. So in L raised to A here is 1. Next, M1 is kg, M2 is gram, because SI system, CGS system. Raised to 1. Why? Because M1 is there. So raised to 1 into S by S, because in both SI and CGS system unit of time is same, that is second. So S by S raised to minus 2. So here you can see that 1 meter is 100 centimeter. That conversion you should know. 1 meter is 100 cent. So I can write meter as 100 centimeter divided by centimeter raised to 1. 1 kg is 1000 gram. So 1000 gram divided by gram raised to 1 into second get cancelled. So 1 raised to minus 2. 1 raised to anything is 1 only. Therefore, just neglect this. So centimeter get cancelled, gram get cancelled. So what remains? 100 into 1000. 100 I can write as 10 raised to 2. 1000 I can write as 10 raised to 3. So 10 raised to 2 into 10 raised to 3 is 10 raised to 5. So N2 I have obtained as 10 raised to 5. So 1 Newton is equal to 10 raised to 5 dyne. Similar exercise you can note and you can prove that 1 joule is equal to 10 raised to 7 erg. Joule is SI unit of work or energy and erg is CGS unit of work or energy. Next application is derive relations using dimensional analysis. The question is like this. The time period of a simple pendulum depends on the length L of the pendulum and acceleration due to gravity G. Obtain the expression for the time period. How to do this? So what is given is T is proportional to L raised to X, G raised to Y, because we don't know the power of either L or G. That's why I am writing as X and Y. X and Y are the unknown constants to be determined. If I remove the proportionality constant, I can write equal to sign and write as T is equal to K L raised to X G raised to Y. Call this as equation number 1. Now taking dimensions on both sides, so dimensions of T I can write as L0 M0 T1, because L0 M0 both are ones, it is simply T. Okay, so K has no dimension because it is a constant and L is there, so dimension of length is L1 M0 T0 raised to X. L raised to X is there. And what about G? It is acceleration due to gravity, so it has the dimensions of acceleration. Acceleration dimension is LT minus 2. So how can I write? L1 M0 T minus 2 raised to Y. So what it becomes? L1 is here and L1 raised to Y is there. So it becomes L raised to X plus Y. Then M raised to 0 into M raised to 0 is M raised to 0 only. And T raised to 0 and T raised to minus 2y. When they are multiplied, it becomes T raised to minus 2y. Now after that, equating the powers of L, M, T on both sides. So what happens then? So you can easily see that T power here is minus 2y, T power here is 1. So I can write as minus 2y is equal to 1. So from that I can write as y is equal to minus half. Then what about the power of L? X plus y is equal to x plus y is equal to what? 1. So from that x plus y is equal to 0. So from that x I can write as half. So substituting these values back in equation number 1, I get T is equal to K root L by G. Actually, experimentally, the value of k is 2 pi. Therefore, t will be 2 pi root L by G. 2 pi root L by G. So, like this, we can derive the relations using dimensional analysis. Finally, the limitations of dimensional analysis. Dimensional analysis na ಮಿತಿಗಳು ಏನು? First limitation is that it cannot determine the value of proportionality constant in the equation. Just in the previous slide, we saw the value of k we could not determine. So that is one of the limitations of dimensional analysis. It can only test the dimensional consistency but cannot be used to obtain the exact relation. Exact relation obtain ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಕೇವಲ dimensional consistency, dimensional ಸ್ಥಿರತೆಯನ್ನು ನಾವು ಅದರಿಂದ ಟೆಸ್ಟ್ ಮಾಡಬಹುದು ಅಂತ. And it is not useful to study the relations containing trigonometric and exponential functions. ಒಂದು equation ನಲ್ಲಿ trigonometric functions, ಉದಾಹರಣೆಗೆ sin, cos, tan ಈ ತರ, ಅಥವಾ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ e raised to something ಇತ್ತಂತಂದ್ರೆ ಅದನ್ನ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಅಂತ ಇಕ್ವೇಶನ್ಸ್ ಅನ್ನ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ ಡೈಮೆನ್ಷನಲ್ ಅನಾಲಿಸಿಸ್ ದಿಂದ. Last limitation is it is useful only when product is involved, not the sum in the relations. ಉದಾಹರಣೆಗೆ, ಸೊ ಈ ಇಕ್ವೇಶನ್ ಅನ್ನು ನಾವು ಸ್ಟಡಿ ಮಾಡಬಹುದು ಡೈಮೆನ್ಷನಲ್ ಅನಾಲಿಸಿಸ್ ಇಂದ, ಬಿಕಾಸ್ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಇನ್ವಾಲ್ವ್ಡ್ ಹಿಯರ್, not this one. Here there is sum. So when sum is involved, we cannot study such relations using dimensional analysis. Okay, thank you for your attention. Thank you.